All right, everyone, thanks for joining us. Welcome to the deep dive. You've sent in, well, quite a stack of sources this time. They paint this incredible, truly global picture of hazards unfolding right now, June 18th and 19th, 2025. Think of this as your shortcut, really, to understanding the complex forces shaping things. Our mission today, unpack these reports, figure out what they mean for you, and maybe look a bit ahead.
Okay, so let's dive right in. What's happening right now? Your sources are highlighting some pretty intense weather, North America, for instance.
Yeah.
Big heat wave, this heat dome phenomenon.
Right.
We're talking borderline dangerous temperatures for cities like Chicago, New York. But get this, while that's happening, Hurricane Eric is out in the Pacific, rapidly strengthening, already hit Category 3, and it's directly threatening Mexico.
It's that contrast, isn't it? The simultaneous extremes. That's what's really striking here.
Yeah.
You've got this heat dome acting like a lid, trapping all that scorching air over major cities. It pushes temperatures up for days, puts a huge strain on, health systems.
Right. But then, like you said, you look south, parts of the U.S. like Oklahoma, and they're expecting, over 3, maybe 5 inches of heavy rain?
Exactly. Multiple extremes, not just one thing. And it's not just North America, is it? I mean, the sources show Europe dealing with similar record stuff.
Oh, absolutely. Across the pond, you've got Spain, southern France. They're seeing 40 degrees Celsius heat waves.
Wow, 40 C.
Yeah, intense. And what makes it worse are these unusually high overnight lows. There's just no relief.
Right, no cool down at night.
Exactly.
Yeah.
And here's the crucial part. Your sources really hammer home. Human-caused climate change. It's made this specific event at least 5 times more likely.
5 times?
Yeah, and it's directly impacting, 94% of Spain's population? It really shows how global these immediate weather threats are becoming, how pervasive.
Okay, wow. So we've got the atmospheric stuff, the weather pressure, but what's also striking reading through these sources is the ground is moving too, and even things happening way above us. Just yesterday, right? Indonesia's Mount Leutobi-Laki-Laki erupted,
That's right.
spewing this, an 11-kilometer ash plume. That's huge.
Huge, and the impacts are immediate flight cancellations into Bali, for example.
Yeah.
And tragically, 1 fatality reported already.
Ah.
Yeah, and it just adds, another layer to this already complex picture. Volcanic activity isn't directly tied to climate change in the same way, but it's another powerful natural force we're dealing with.
Okay, so volcanoes and then space weather.
And then space weather, yeah.
Yeah.
Your sources picked up on something significant there, too. A strong R3 radio blackout observed on June 17th.
R3?
Yeah, R3. It came from an X1.2 solar flare. Now, R3 isn't just jargon. It means real disruption, high-frequency radio navigation system.
So like impacting flights, GPS.
Exactly. Commercial flights might have communication issues. Emergency services relying on GPS could face problems. It's a pretty potent flare class.
Yeah, X-class flares are serious business. It really shows how these hazards aren't just, weather. They hit our infrastructure, how we function.
Precisely. And the thread tying all this together, which your sources make incredibly clear, is the background context. Accelerating global warming.
Right.
All these immediate events, the heat, the storms, the eruptions, even the space weather impacts, which can be sensitive to atmospheric conditions that are happening on a planet that's warming up fast. The long-term projections, they're pretty stark.
How stark are we talking?
Well, there's apparently a 70% chance now that the 5-year average warming for 2025 to 2029 will actually exceed 1.5 degrees Celsius above pre-industrial levels.
Okay, 1.5 degrees, we hear that number a lot. For listeners, maybe remind us why that specific number is so significant.
Sure. That 1.5 degree C mark, it's seen by scientists as a critical threshold. Crossing it, even as an average over 5 years, means we're really stepping into territory with potentially much more severe, maybe irreversible climate impacts.
Okay.
And we're already seeing the effects, right? Human-caused climate change has increased global disasters, like 5-fold over just 50 years. Yeah. And a key reason, a mechanism for that, is simple physics. Warmer air holds more moisture.
Right. I remember reading that. About 7% more per degree.
Exactly. About 7% more for every degree Celsius warmer it gets. So when it does rain, it really comes down. More intense, damaging floods. But, and here's the paradox, it also means the periods between rain events can become longer, drier. So you get worse droughts, too.
So it fuels both extremes, floods and droughts.
Precisely. It's that double-edged sword explaining these kind of paradoxical situations we're seeing play out right now.
So bringing this all together, What's the takeaway for you listening right now? We've looked through your sources, seen these immediate, intense threats, weather, volcanoes, even space weather, all amplified, it seems, by this rapidly warming planet.
Yeah, and the real challenge, as these sources really highlight, is managing all these complex things, often happening at the same time.
Right, the simultaneity?
Exactly. The impacts aren't uniform either. So how do societies get ready for, say, drought in one place and massive floods just next door? Add in volcanic ash grounding flights, maybe a solar flare knocking out communications.
While knowing the underlying trend is getting worse.
While knowing that underlying warming trend is accelerating. Yeah. I think this deep dive really shows it's a compelling call for highly localized, really flexible adaptation strategies. We need global awareness, absolutely, but the action needs to be hyper-local.
It really makes you think about how interconnected everything is, doesn't it? The atmosphere, the ground, even space. All linked.
It certainly does. It poses a profound question about resilience in the face of such complex interacting planetary systems, something to really mull over.